Hello everyone, in this video we're going to discuss how we can derive the acceleration and velocity of an object describing simple harmonic motion. So if we consider an object which has been able to describe a circular path like this, then we are going to consider points, for example N and Q, to be passing through or describing simple harmonic motion. Q will be having a displacement x along the x-axis, and N will be having describing simple harmonic motion in the y-axis, and its displacement can be taken as y. So we want to see that actually acceleration can be omega squared x, or acceleration can be omega squared y, depending on which axis you take. So whichever axis you take, you can have all these equations applicable. And velocity will be omega, then the square root of r squared minus x squared, or you can have v equal to omega, then square root of r squared minus y squared. So let's begin and see how to come to this. So if I take the x-axis, okay, so I'll have displacement equal to x. So when I talk about velocity, then I'm talking about displacement out of time. Yes, so I'm talking about velocity, which will be the x dt, and this will be the same as what is x. Our x is so we shall differentiate. This is r cos omega t. This could have been cos theta. So we know x is equal to cos theta, but we know that theta is the same as omega times t, because theta is the angular displacement, whereas w is the angular velocity. So if I get the angular velocity, I multiply by the time, I'll get the angular displacement. So this is where it comes from. So what does that mean? V will be, I differentiate d by dt of r cos omega t. So what does that mean? I will have r omega sine omega t. This is having a negative, but I'm going to take the magnitude. But taking magnitude, that negative tells us that velocity is directed towards the center. So as the object is moving away, we see that velocity will be directed towards the center. In other words, in the opposite direction. So taking the magnitude, our V will be R omega sine omega t. Now, what does this mean? I can eliminate this sine omega t. Sine omega t is the same as sine theta. So which is equal to 1 minus cos squared theta, everything under root, from the first law of trigonometry, where we know that 1 is equal to sine squared theta plus cos squared theta. So from there we can get the expression for sine theta. So meaning V will equal to R omega sine theta, okay, which is the same as sine omega times the square root of 1 minus cos squared theta. So but cos theta is the same as x out of r, according to the geometry of this circular path. So we see that cos theta is equal to x out of r. So V will be r omega, okay, times the square root of, this is 1 minus x squared, so it becomes r squared minus x squared, everything out of r squared. So this becomes r omega divided by r square root of r squared minus x squared. So V, which will be the instantaneous velocity of any point, okay, described in simple harmonic motion, will be omega square root of r squared minus x squared, whereby x is the displacement along the axis chosen, which is going to be the x-axis. So for displacement y, it is still true that V is equal to omega, then square root of r squared minus y squared. Then what about acceleration? Acceleration, we shall see that this acceleration is also going to be dv dt, because we know from the definition for acceleration, it's the rate of change of velocity with respect to time. So we know that it is change in velocity over change in time. So we can differentiate velocity with respect to time, so that I have dv dt will be d by dt of r omega sine omega t. So this is equal to, if I take now the negative that was there, I'll have negative r omega squared cos what? Cos omega t. But cos omega t, we said, is the same as, okay, if we take r, okay, r cos omega t is the same as x. So if I bring it up there, I'll see that acceleration will always equal to negative omega squared times x. If I also take the magnitude, taking the magnitude of acceleration, then our acceleration will always be omega squared x. So we can see that there are two important points to note. One is that acceleration is directly proportional to, okay, the distance or displacement from the fixed position. And two is that this acceleration is always directed towards the mean position. That's all. So in the next video, we're going to be looking at an example on how to apply this. Thank you.